So today I will discuss on the anisotropic effect in alkene, alkynes, aldehydes and aromatics. Okay. Let us first start with the revision of the earlier things that we have done already. Here, as I have already explained you, if there is an alignment of the environment with the external magnetic field, the nucleus gets de-shielded. Means here the environment is HB and HB is having an alignment with the external magnetic field. See, this is the arrow, this is in the same direction. So it is in alignment with the external magnetic field, and therefore HA is getting de-shielded. De-shielded means it will require lesser magnetic external magnetic field, and it will have delta value, larger delta value. And when it opposes, it will HA will be shielded and it will require more magnetic field, and the delta value will be less. Okay, that is a revision part. So here we will apply the same concept here. So first of all, let us see what is anisotropy. So here you can see anisotropy means uneven magnetic field in space, that is, different region of space are characterized by different magnetic field. Now, in case of pi electrons, okay, the pi electrons are having an important characteristic difference with that of the sigma electrons. In some cases, such as alkenes, alkynes, carbonyls and aromatic compounds, the chemical shift cannot be explained only on the basis of the fact that we have already discussed, like electronegativity. The carbon atom in the acetylene is more electronegative as it is sp hybridized than in the carbon in ethylene, that is sp2 hybridized. But the chemical shift value for acetylene protons are less, more de-shielded, that means, than the ethylene protons. Okay. So here, even though we find that this is in notation, this is sp2 hybridized, this is sp3 hybridized. So it means that it is in more electronegativity, it is having more than this one. But even though it is having more electronegativity, this is having a lesser delta value than this. Otherwise, what we have seen in earlier discussion, if the electronegativity is more, this is getting, the proton is getting more de-shielded and delta value is high. Whereas this is not, this is rather contradictory with our explanation in the previous classes, whatever we have discussed. Now, what is the result? This can be explained only with the concept of anisotropy, which means uneven magnetic field in space. Now, let us see how it is. It can explain that part. Okay. So let us see. In fact, a proton experiences three different fields: the applied field, the induced magnetic field generated by the sigma electrons, and the induced magnetic field generated by the pi electrons. The pi electrons are more polarizable than sigma bond electrons. That is one important difference between pi electrons and sigma electrons. Therefore, the induced magnetic field due to the pi electrons movement is stronger. Okay, strong secondary field that perturbs nearby nuclei than that generated by the sigma electrons. Depending on the position of protons in the induced magnetic field, it can be either shielded, shielded means small delta value, or de-shielded means large delta value. Now, first of all, let us see the alkene example. Now, here you can see the structure of alkene. Now, if this is the applied magnetic field, this is planar, and this is the direction that is perpendicular to the plane. Okay, the magnetic field has been applied. Now we see that the pi electrons are in perpendicular to the applied magnetic field. Now when it is having this direction, what happens is that thus there will be the pi electrons are in perpendicular to the carbon-hydrogen framework. So here the circulation, the electron starts circulating, and it circulates in such a direction that it is perpendicular to the carbon hydrogen. Now what is the circulation? You can see this is the direction. Okay, now here this part, you see this is the arrow, so it is circulating, so this arrow is in opposite direction, whereas this H in this direction, near the H, what is the direction? This is in alignment, means when it is in alignment with this, it is having the same direction. Here are the H, and this is the direction that is it is in alignment with the applied magnetic field. Therefore, it is de-shielded. Let us read this word. Okay. An alkene molecule an alkene molecule in an external magnetic field is so oriented that the plane of the double bond is perpendicular. So here, first line explanation, this is the direction and this is the plane. So this plane and this direction are in perpendicular. Next line, thus the circulation of the pi electron is perpendicular to the carbon hydrogen framework. So since this is the direction, okay, and in this direction the electrons will circulate. Okay, so here what we see, this in this direction when it is circulating, it is in perpendicular to the carbon hydrogen framework. As a result, the induced magnetic field caused by the circulation, now this is circulating and this will induce a magnetic field, and this magnetic field is in opposite direction to the applied magnetic field around the carbons. So this is in opposite direction and these two are the carbons. Around the carbon it is in opposite direction. So next is what? Next is, and in the direction of the applied field in the region of olefinic protons. Now here what we have is the protons. These protons are, this is in the induced magnetic field due to the circulation of the pi electrons. This is in the direction of the applied magnetic field. So this is the direction and this is also in the same direction. So it is in alignment. So therefore the olefinic protons experiences greater field strength since it is in alignment, and therefore requires lesser magnetic field to resonate, and the chemical shift is higher. Okay, let us see the alkyne part. Now if we have this alkyne part, what we have, and this is the applied magnetic field and it is in direction and of the pi electrons. Now the pi electrons are circulating. This circulation is also in the same direction, means it's parallel to the applied magnetic field. Now you see this is in parallel. Now here what we see, these protons, the induced magnetic field are in opposite direction. This is the direction. So it is in opposite direction to the applied magnetic field. This is also same. This is opposite direction. See the arrows, and this is the applied magnetic field. So therefore it is in opposite direction. So since it is in opposite direction, it requires more magnetic field to resonate, and therefore it has a smaller delta value. Okay, smaller delta value. So here you can understand, even though it is sp hybridized, it is having more electronegativity, but it is not de-shielded. It is rather shielded. Okay, so that is what is anisotropy. And let us see what is the next topic, carbonyl compounds. Here you see this is the CO pi electron, and it is in perpendicular to the applied magnetic field. The pi electron circulates, and this circulation is in the direction of the applied magnetic field. See, this is in direction with the applied magnetic field. And now what happens is that this H experiences reinforcement, means it is aligning with the applied magnetic field. Therefore it is requiring lesser magnetic field to resonate, and the delta value is less. Okay, so it is, just see this direction. This direction will tell you that it is in alignment and it is reinforcing the external magnetic field. Therefore requires lesser magnetic field to resonate, and hence it is getting de-shielded and it is requiring larger delta value. Now same is the aromatic protons, little difference is there. Just see this diagram. Here you have the applied magnetic field. Just see this diagram. So here it is the applied magnetic. This is the plane. This is the plane of the electrons. Now this is resonating in the direction perpendicular to the direction of electrons. See, then when the magnetic field is applied perpendicular to the plane, the circulation of the pi electrons produced a ring in current which induces a magnetic field perpendicular to the plane of the ring. Okay, so this is important. So it is shown here the exactly means it is perpendicular, and what we have two different environments. See, this edge is in alignment, this edge is also having a reinforcement, whereas these two edges are having opposite, means it is having opposite direction. So therefore this is getting deshielded and this is getting shielded. Okay, so opposite direction means shielded, this is getting deshielded. So therefore this delta value is little higher and this delta value is little lesser. Okay. That's what is the topic today. Now let us see the next topic, that is the application of NMR. Now here you see what are the informations that you get from this. Okay, we have this spectra, we don't know this compound, what are the information we are having. Only thing that we have is the molecular formula, that is C4H8O2. Now what we see here is that there is a singlet, there is a triplet and there is a quadruplet. Now quadruplet will tell us that it has an environment of 3 hydrogen. Triplet will tell us it has an environment of 2 protons, 2 active protons, and singlet will tell us that there is no such environment. So from here what we get is that, supposing, and now next information that we get is what is the height of this peaks. Now here what we have is, this is the height of the peak, means there are 3. If you calculate, it will tell you that there are 3 protons. This is also 3 protons, even though it is short in height. If you calculate this height, and this height and add them, you will find it is coming to the same level, and similarly it is coming to what, such a level that it will reach up to this much. Okay, when you add these 3 heights, these 4 heights, 4 lengths of the peak, then it will come almost like this. So it can be told that it is for 2 hydrogen, it is for 3 hydrogen, it is for 3 hydrogen. Now if you calculate, what is the formula given? It is H8. So if you calculate 3 plus 3 is 6 plus 2 is 8. It is quite matching with the thing. Now what is the thing? Now let us suppose next thing, that is how we can rearrange that it is not having any splitting. First thing is CH3 can be the group, and this CH3 can be bonded to oxygen. So if it is bonded to oxygen, okay, what we have is, yes, if it is bonded to oxygen, what we have is, it is having 3 hydrogen and it is not having any kind of splitting, because it is not having any nuclei to split it. Next is, if we are having COO, means there are 2 oxygen, so C double bond O, single bond O, COO, CH3. That is one part. Next we have to the carbon bonded to the ketonic carbon. If we have CH2 and CH3. Now CH2, this CH2 can be the peak of this, and it is having little bit deshielding, because it is bonded to C double bond O. So this CH2 is bonded to C double bond O and it is getting reshielded, and therefore delta value is higher. Whereas CH3 bonded to CH2, it is not having any deshielding. So therefore it is having shielded. It is rather shielded, and therefore the delta value is quite less. Whereas the CH3, which is bonded to oxygen, okay, it will be having a little bit deshielding, but not that much, okay, not that much, because it is the proton which are bonded to carbon, that particular carbon is not